This is the work kinetic energy theorem example 1. Alright, so this is a Hot Wheels booster, and it's made for the car that comes in one side and then goes faster as it comes out the other side. So this booster does work on the car to change its kinetic energy. Now we're going to be using our energy methods to calculate the car's final speed after leaving the booster. So the booster applies a force of 2 newtons, and it touches the car for 2 centimeters. The car comes in at 3 meters per second. Its mass is 5 grams, so I want to find out what the final speed is when it comes out the other side. Inside the booster there's a rubber wheel, and the rubber wheel spins and then it touches the car. So it touches the car for a distance of 2 centimeters. That's how I know the distance that the booster applies to it. So to solve this, I'll look at the energy before the booster. That's going to be the kinetic energy. And then the booster, its force and displacement move the same direction, so therefore it's doing work on the car. So I'm going to add the energy that it does. And then I'll have the energy afterwards, which is going to be all kinetic energy. So the initial kinetic energy plus the change in kinetic, which is the work, equals the final kinetic energy. That's going to be the work kinetic energy theorem. So I'll start with my summations. Sum of all the energy on the right side plus the work equals sum of all the energy on the left side. So that's going to describe the law of conservation of energy, or in this case the work energy kinetic energy theorem. Then we'll show how the law is used. Then I'll define the energies with my equations. 1F mv naught squared plus Fd equals 1F v squared. 1F v squared plus 1F mv squared plus Fd. So I'm just rearranging things. So I can isolate my unknown, multiply everything by 2, then divide everything by m. Notice m doesn't divide out, it just divides into 2Fd. And then I can find the final velocity by taking the square root, put in numbers and units. Notice that I had to convert centimeters to meters and grams to kilograms. Do the math, and I get 8.49 meters per second.